So hello and welcome to tutorial number 4 in our series. In this tutorial I will show you how to use more than one buffer in OpenGL. So in the last video I show you how you can draw multiple triangle using one buffer. However, there is another way to do that and actually using multiple buffers, and that's what we will be doing in this video. Then I will show you how you can put different colors to your objects. We will also be implementing our first motion, and finally I will show you how you can display some debug information, namely the number of frames per second which we are drawing in this tutorial. Before we go into the Java code, there is some math which you should be familiar with. I will not be explaining this math in depth, however I want to show it quickly to you. For that I will be using this website, which they have a nice page here about geometric transformation. This is a nice page which you can maybe read before going into the tutorial. In this page, they start first by explaining the translation and rotation in XY plane. So basically in 2D using a 3x3 matrix. Then they move to the 3D space and they show how we can use a 4x4 matrix to represent rotations and translations. Let's see, for example, how translations can be represented in a 4x4 matrix. Let's assume we have a point which has the coordinates x, y, z, and we want to apply a translation with a value p, q, r, or respectively on x and y and z axes. So for that, we add this one here to our point coordinates and then we multiply it by this 4x4 matrix. This vector matrix multiplication now will result in a 4 vector which has an x component shifted by p, a y component by q, and a z component by r. And here is the inverse transform. Similarly for rotation, so for example here we have a rotation around the x-axis, and then here a rotation around the y-axis, and then about the z-axis, and so on. We can also combine multiple transformations, so multiple rotations or rotation plus transformation, by simply multiplying those matrices, and this is shown in this page at the bottom here. Yeah, and I also noticed that the projective transformation is also explained here. So it would be good if you can go first through this page before you go into the tutorial, or actually you can maybe look at the tutorial, and if you notice that you need more information, you can come back to this page. I will put the link to this page in the description of the video. In the last video, we drew these two triangles. What I want to do first here is to make these two triangles a little bit apart. So I will move these two vertices for the second triangle a little bit to the bottom. I also moved now these two vertices a little bit up. So as you can see now, the two triangles separated. So as you can see now, we drawn two triangles using one buffer. So actually we can draw as much triangles as we want. And this is how usually we make more complex objects. So if you want to make a rectangle, for example, you just put two triangles beside each other so that they make a rectangle. Let us change the coordinates of these two triangles so that they make a rectangle. Now let's run. As you can see, we have now one rectangle made up of two triangles. The first triangle starts at this vertex, then goes down, then to this vertex, and here. Yeah. The second triangle starts by this vertex, goes to this vertex now here, and then this the third one, making the second half of this rectangle. Using the same trick, we can go further and make more complex objects. Note now that all these triangles are contained in one buffer. So this is the buffer on the CPU side, and the one buffer we are creating on the GPU side is stored in this variable GL array. What I want to show next is how to make two buffers and draw maybe two rectangles. So first let's copy these vertices. Let's make this rectangle below the first one. Let's define a variable to hold this array. Let's just call it the array2. Then we create also this buffer in this function on surface created. That's it. So here we create the first buffer as before, and now this is the second buffer. Now in the draw function, we need to draw this array, and for that we only need to bind the second array and then run the same draw command. Let's see. As you can see now, we got two rectangles. I want you to remember now that binding this vertex array runs all the commands that we implemented in the function sent to GL Now this is the function. So send vertex data to GL. When we bind this vertex array, we are binding the array buffer with the data of the vertices, the corresponding vertices, and we are enabling the position, and we are telling OpenGL the attributes of this buffer. This is very nice. Let's say now that we want to have two different colors for these rectangles. To do that, we need to pass these two colors to the fragment shader. Remember, we have two shaders, one vertex shader and one fragment shader. So in the fragment shader, we are now fixing the output color to be white. To make this color variable, we need to define it here in the vertex shader first as uniform input. As you can see here, we can define uniform from a vector from vic3, so it contains three floats, and let's call it color, a color. Let's call also the position here a position, just to keep the same names. Now, one word about these two definitions. So when we define a variable as in, that means it is an attribute, and it changes per vertex. So that means each vertex will have a different position. However, when we define something as uniform, then it changes once per program. So basically, all the vertices will have the same colors. If we want each vertex to have different color, then we need to define this color as an input or as an attribute, basically, and then we need to put this attribute in a buffer like we did in the positions, and tell OpenGL how to retrieve it. We will do that later. For now, let's just keep the color like this, and let's define also one output variable, call it out color, and this out color will be simply the input color which we have. Now the output of the vertex shader out color will be passed to the fragment shader. So in the fragment shader, we can define here an input which is called out color. However, now we have used the same name of the variable. Let's call this variable here is fragment color. And now for the fragment color, we use the input color, which has three colors, the red and blue and green values, and we add one for the alpha. And that's it. Now we actually can pass multiple colors, and that's it for changing the color. We can now pass the color from our Java application. So we already did some name changing. Let's fix that. Okay, so we have a position and a color. So here we need this attribute to be a position. This will fix the attribute. Now let's see how we can change the color. So after we use the program, we can get the color. However, we need now to use a function get uniform. Now we can set this uniform. Let's choose now the colors for the first rectangle. Now after we draw the first rectangle, we can change the color again, and that would be used for the second rectangle. Let's now run the program. It seems that something is going wrong. Let me fix that and come back to you. Okay, so I found the error. Let's run the debug mode to show you how I found the error. So I run the program in the debug mode. And as you can see here in compile program, it jumps to this breakpoint, which I put here if an error happens while compiling the shader. And you can see now that this error tells us that there is this variable position which is undeclared, and that would be in the vertex shader here. And as you can see here, position. So we changed this name to a position, but we kept this here. So now if we run, so it's working, and now we have a yellow color for the first rectangle and a white color for the second one.